In station 3 we have the ice and water. So we first of all have to think about how we want to draw the water. We know the formula for water is H2O. So I'm going to draw an oxygen. Usually we use red for oxygen. I'm going to use an outline in black. Usually in molecular models, hydrogen's white. It's probably that Mickey Mouse model that you've seen before. So there's H2O. So in the solid phase, we know that the molecules are all lined up in nice neat rows. They're very organized, relatively close together. So that's how we're going to draw this. So I'm just going to keep repeating this model over and over again. Make sure they're lined up. Now last year you learned that water's polar. The oxygen happens to be slightly on the negative side. The hydrogen happens to be slightly on the positive side. So I'm going to make sure that I line up those positive H's with the negative O's. That pattern just keeps repeating itself. So that's probably good enough for now. Now a lot of times in the liquid phase is less dense, so you'd start showing those molecules starting to spread out a little bit. But water is one of those special substances where the molecules actually get closer together. That's what allows an ice cube to float, because the solid phase ice is actually less dense and it floats. I'm just going to start showing how they're not quite as organized, they're not quite lined up as well. They actually get closer together, and that's why when the ice cube melted, it didn't take up as much space, because those molecules were actually closer together. Now, as far as a physical change or a chemical change, if you take a look at what was bonded at the beginning and what was bonded at the end, we still have an O bonded to two H's, so this would simply be a physical change.